Hello everyone, hope you're all doing well. Today I'm solving the week 8 Math CE quiz. Yalla, let's start. Question 1. A lab technician has 2 pints of acid that he will dispense in cylinder tubes, each having a radius of 1 and a height of 4. He fills each tube with diluted acid up to 85% of its capacity. Given that 1 pint is 29 cubic inches, what's the maximum number of tubes he will be able to prepare? Okay. When they say the number of tubes we want to prepare, that means the volume of the liquid we have, so the volume of our acid, over the volume of our tubes, because they want to know how many of these tubes we could get. So the volume of our acid, they said that we have 2 pints of our acid, and each pint is 29. They say here 29, so just use that. Okay, so that means we have 2 times 29 over the volume of our tubes. Now, they said each tube is a cylinder and has a radius of 1 and a height of 4. Okay, the volume of a cylinder is what? It's going to be pi r squared times height. Substitute, we get pi into 1 squared times 4, so you get 4 pi. Now, one more thing, they said here that he fills each tube up to 85% only. So he doesn't use the full tube, he only uses 85%. So here we multiply by 85%, and you get 17 over 5 pi. Okay, so now we take this and put it back in our equation. So it's 2 times 29 over 17 over 5 pi. You get around 5.4. Okay, so the full cylinders we're going to be able to prepare, the full tubes are going to be 5 only, right? We could fill 0.4 of an extra one, but that's not full. Okay, so it's not actually fully prepared, so we choose just 5. Number 2. This question came before last week. They're asking the interval of the graph decreasing. When they say increasing, decreasing, or anything like this, you need to do the table that we get the saddle points from the derivative and that. So here, the first thing we're going to do is derive, right? The original equation is minus x cubed, so that means we get minus 3x squared plus 27. Okay, if you put this on your calculator, to get the roots, you get x is equals to minus 3 and x equals to 3. So now we can start making our table. X, y prime, and y. Yeah? Okay. So we put in our x values, make sure they're in order. So going up in order, right? So minus 3 then, 3. Put these, because these are equal to 0. And now we could test for points before minus 3, in between both of our values, and after 3. So before minus 3, I'm going to put minus 10. Between these two, I'm going to put 0, and after here, I'm going to put 10. Now take each of these new values, put them in our derivative, and test. You get negative or positive. We don't care about the actual number, only the sign. If you put in minus 10, you get a negative number. Put in 0, you get positive. And same thing with 10, you get a negative number. So now we have the signs, we do our arrows. So this minus plus minus. So now we could tell that the graph is going down when x is less than minus 3, right? So that means x less than minus 3 is decreasing, and where else it's also decreasing here when x is greater than than 3. So when x is greater than 3, it's decreasing. Okay, so that's what we choose. The options, we find x is less than minus 3 or x is greater than 3. Number 3 also came last week, but this is just a definition. I can't help you with this, just memorize. The inflection point changes the sign as the graph passes through point A and f of A, and the f prime prime of A equals 0. Once again, just memorize. Okay, number 4. We have a rectangular sheet or paper, size 4 centimeters by 20. Equal squares of side x are removed from each corner, and the edges are then folded to make a box. Okay, it helps if you draw it. Okay, so I'm gonna do that. We have a paper, right? It's 4 and this is 20. Now they're saying we cut out from each corner x, like squares of side x. So that means each of these is x, yeah? Height, width, whatever. These are all x, yeah? So now this is the box we have. Okay, they want to find the volume when we have this box folded up. Okay, the volume of a box normally is what? It's the base times the height. Okay, now for us the base here is gonna be this times this. لا ما bad. It's gonna be this part times this part. Okay, so this part up top here is gonna be what? It's gonna be 20 minus 2x, right? Because we removed x from here and we removed x from here. And same thing with the 4. Here it's gonna be 4 minus 2x because we moved x from here, x from here. Okay? So these multiplied together give you the base. So I'll just write that down now. 20 minus 2x times 4 minus 2x. Now once again, the volume of a box is the base times the height. Now the last thing we have the base already. This is the base. So we need to multiply by the height. Now what's the height? Is just x. It's like if you could try to visualize it, it would make sense, but if you can't, it's fine. Just remember it's x, okay? So the height is gonna be x. So this أصلا خلاص, this is what they want. You just go here searching for it. Now you have, here's the option, okay? And for this second part here, I need you to like think about this. If you have this box, right? This side is 4 and you're cutting off x. If we cut off half of this, right? So this part's gone and this part's gone. So خلاص, that won't work out. We're not gonna get a box, yeah? So that means our x, okay, if we cut off x and x, our x has to be less than half of our side. So half of our side is 2, right? So that means our x has to be less than 2. Okay, you're always going to choose the smaller side to take the half. So we're not going to choose the 20, we're going to choose the 4. Half of that is 2. So this is our option again. Okay, number 5, the surface area of a cylinder with base radius r and height is given by the formula. Its volume is given as whatever. If the volume is equals to 3,456 pi, then the surface area can be expressed as this, where b is a whole number which they want. Okay, the first thing we're gonna do with these types of questions is try to find our height. Okay, so our height here, if we reshape this formula, we get our height is equals to the volume over pi r squared. Now what's our volume? They said here that our volume is 3,456 pi. So I'll write it back up here. Height is equals to 3, 4, 5, wait, it's handwriting. Yeah, good. 3, 4, 5, 6 pi over pi r squared. Okay, this is our height. And they want the formula of the surface area. Okay, it's easy. We're just gonna substitute our height into the surface area. So we go, it's 2 pi r times the height, which is 3, 4, 5, 6 pi over pi r squared plus 2 pi r squared. Okay, all we did is substitute our height here. Now if we solve for this, if we simplify, we get our s is equals to 6912. This pi cancels out with this pi, this distributed into this r cancels out with this, so 6912 pi over r plus 2 pi r squared. Okay, so here we could compare this part to our formula. So we get, they want 6912. Okay, Part B, the radius r for which the surface area is minimal is what? Okay. When they want the surface area minimal, maximal, or whatever, you need to derive the equation we have now. So the equation we have now is what? The surface area, which was, I'll write it down here again, which was 6912 pi over r plus, what was it? 2 pi r squared. Okay, this we need to derive it. So s prime would be, I'll just wait first, I'll get it into a form where I could actually start deriving. So we need to take this r up, so it becomes 6912 pi r to the power of minus 1, yeah, plus 2 pi r squared. So now we could actually start deriving. So s prime would be, for this you just do the chain rule, minus 1 times 6912 pi, and then times r to the power of minus 2. Yeah, we're just multiplying by the coefficient, by the power, and then subtracting 1. Plus 2 pi r squared, and derive it, you get 4 pi r. Now simplify this, it's minus 6912 pi over r squared plus 4 pi r. Now after you derive this, you're going to want to equate this equation to 0. So we have this, put it equals to 0. You could do shift solve, in the end you get, instead of r on your calculator, just put x, shift solve, you get r is 12. Number 6, this is the same thing, but they just listed out the steps for you, so it makes it a bit easier. So they said here, remember the first thing we're going to want to do is find our height. Okay, we have our volume is what? Pi r squared times height. They gave it to us here. Okay, if you reshape this equation, you get the height is equals to volume over pi r squared. Substitute the volume, which they give here, if the volume is 2000 pi, so 2000 pi over pi r squared. Pi cancels out, so that's what you get, 2000 over r squared. Now part B, in terms of r, the surface area is equals to what? Once again, we're going to take our new height and substitute it into our surface area equation. So our normal surface area equation is 2 pi rh plus 2 pi r squared. Now we take our height and substitute it into this. So it's 2 pi r times our height is 2000 over r squared plus 2 pi r squared. Simplify this 2 times 2000, you get 4000, and this 4000 pi, and then r cancels out with r squared, just all this over r, and then this part stays the same, 2 pi r squared, and that's your answer. They want this part only, so I give them. Now part C, they want us to derive this equation. Okay, we'll write it down again in a way we could start deriving. So that means I need to take the r up, so it's 4000 pi times r to the minus 1 plus 2 pi r squared. Now I could start deriving. So it's going to be minus 4000 pi over r squared, okay, plus 4 pi r. Once again, they only want this part, so we just give that. Now the part D, they want you to equate this to 0 and shift solve, basically is what they want. So you just take the part we got from here, over x squared plus 4 pi r equals to 0. Shift solve on the calculator, you get r is 10. Okay, this last part I'm not actually sure, I couldn't figure it out, but if I do figure it out, there's another question like this, I will make a video or I'll just make a PDF or something. I'll let you guys know. This question I didn't take too long because it's the same as the question we just solved. and it's even easier. They just listed out the steps for you. Okay, number 7. Mark is in a boat 2 kilometers from the nearest point A on a straight shoreline. Down the shore, 8 kilometers from A is his home at B. Suppose that Mark can row at 7 kilometers per hour and run at 9. Let X denote how far from A Mark's land his boat, and let T of X denote the total time. Okay, it helps a lot if you draw this out to visualize it, okay? So we have the boat is here, right? Here's our boat. And they're saying he's 2 kilometers from a point A. Now this point A is on a shoreline. Yeah, so this is the shoreline, this is the sand and land, whatever. Okay, we don't care about this. But they're saying down this shore from A, 8 kilometers, you get his house at B. Right, that's what they're saying. Down the shore 8 kilometers is home at B. Suppose that he can do this speed and that speed. They want to find in part A the total time. Okay, the time, right, the formula for time is equal to the distance over our speed. Okay, and they're saying that here he landed from A, so he landed at X from A. So you could just draw any line, doesn't matter, and this distance here is X, right? So that means, wait, my bad, so that means this part is 8 minus X. Okay, now this means that he's going to be rowing his boat in the water and he's gonna end up running, right? He's gonna be rowing his boat here. This part he's gonna be on the boat, and here he's going to be running. So we need to add these times together. Okay, we said that the time is the distance over the speed. Now the total time is gonna be the time on the boat plus the time running. Yeah, the time on the boat is what? The distance spent on the boat over our speed. The distance on the boat, you could do Pythagoras theorem. So radical 2 squared plus x squared is this distance here. Yeah, so if you put radical 2 squared plus x squared on the side right now, over our speed at the boat, said is 7 kilometers per hour, over 7, this is our time for the boat. Okay, so we'll keep this aside for now. Now we'll calculate the time running. Yeah, now the time running is going to be the distance spent running over the speed running. So the distance we're running is going to be this part here, right? Oh, my bad. It's going to be this part here, which is, we said was 8 minus x over the speed running. They said was, yeah, it was 9 kilometers per hour is our running speed. So 8 minus x over 9 is our time running. So now if we add these two, write them here again. It's radical 2 squared plus x squared over 7 plus 8 minus x over 9. This is our total time, and they only want this part and this part. 2 squared is 4, so then just put 4, and here 9. Part B, the derivative of this is what? Okay, to start deriving, I'm gonna rewrite our equation here so that we have space. It's what? Radical 4 plus x squared over 7 plus 8 minus x over 9. This is our original equation. We need to derive it. Okay, so first I'm gonna get this into a form where we could start deriving. That means getting rid of our radicals. Okay, so it's gonna be 4 plus x squared over 7 to the power of half, don't forget that, plus 8 minus x over 9. Okay, Rewrite this one more time. 1 over 7 times 4 plus x squared to the power of 1 over 2 plus over 9 into 8 minus x. Now we can start deriving. For this first part, we'll do the chain rule. So it's 1 over 7 times 1 over 2 into our brackets. We keep them the same, to the power of minus 1 over 2, because half minus 1 is negative half, and then times the derivative of inside, which is 2x. Okay, plus now the second part, you derive it, the coefficient in front of x is minus 1, so you just multiply this by minus 1. So instead this would be minus 1 over 9. Okay, this 2 cancels out with here, so this x will bring here, so it's x over 7 times 4 plus x squared to the power of minus 1 over 2 minus 1 over 9. Keep going, so it's gonna, this is a negative and half, so it's gonna be in the denominator and the radical 4 plus x squared minus 1 over 9. Okay, so this is what they want. They want 7, 4 and 9. Just give that. Okay, I sped through this part here. It's because it's just simplifying, there's nothing to explain. Now part C. The value of x that gets marked to arrive home in the least amount of time is. For this, you could put shift solve. You could take this equation, put it to 0 and shift solve, but you get a decimal, right? And here they want it in this form. So here we're gonna have to actually solve it manually and on paper. So this equation, we could rewrite it here. We'll move 1 over 9 to the other side, so it becomes x over 7 radical 4 plus x squared is equals to 1 over 9, right? So that means 9x is equals to 7 radical 4 plus x squared. You could square both sides to get rid of the denominator, so it would be 9x squared equals to 7 radical 4 plus x squared all squared. So it's 81x squared equals to 49 into 4 plus x squared. And you distribute this 49. So I'll do it here. You get 81x squared is equals to 196 plus 14. Equals to 49x squared. Now move this to the here, so it's gonna be 81x squared minus 49x squared equals to 196. Get 32x squared is equals to 196. X squared is equals to 196 over 32. Take this 32 to the other side. So 196 over 32 is 49 over 8. So that means x, hold on, rewrite it here. So we got x squared equals to 49 over 8, yeah? So x is equals to radical 49 over radical 8. Radical 49 is 7, and radical 8 is 2 radical 2. You can put this on the calculator, you get 2 radical 2. And that's our answer. 7, 7. Now number 8 is also a question I don't understand. I couldn't figure it out. If I figure it out, once again, I will let you guys know, either in a video, or if it's simpler than I think, I might just do a PDF. Okay, number 9 is actually the same as number 7, and I just did it, so I'm not gonna do it again. But yeah, hatta you can see it's the same answer, it's the same final answer you get to. Okay, it's the same steps, same everything, nothing changes. Number 10. This is really easy. We have a curve, and they're asking for its derivative is y prime. Let's start deriving. Y prime is equals to 3x squared minus 36x plus 81. They want minus 36, give them minus 36. And now they want to factor it, yeah? So we could simplify this. We could take out the 3. It becomes into x squared minus 12x plus 27, yeah? And this part here is the perfect factor. You could put this on your calculator and you get x is equals to, I believe it's minus 9 and x is equal to 3. Wait, no, my bad, it's x is 9 and x is 3. Now, the curve C has a local maximum at x and a local minimum at x. Okay, here they already gave us everything we need. Just go ahead and draw our arrows straight away. Okay, so that means this point is a max and this point here is a min, right? Here's maximum, here's minimum. So the maximum is at x is 3, okay, maximum is at x is 3, and the minimum is at b, which we got before as 9. This came last week, so not too much time on this. Okay, number 11. The volume V of a reservoir shaped like an open box with a square base of side x is 32. They want, the first part, they want the surface area of this box. Okay, they said open box, right? So an open box means that there's no top to it. So they want the surface area of a box that doesn't have a top. So you don't need to memorize anything. Just know that the box, we said, is a base times height, right? So it's gonna be this base, the bottom, which is what? X times x, so it's x squared, plus each of these sides. So we have this one side here, and this is another side, and we have the sides at the back also, and this side here. Yeah, so each of those sides is actually just x times h, right? It's our x times the height, and we have 4 of those sides, so it's 4xh. That's it, that's all they want. Okay, in terms of x, the height is what? Okay, remember, like the other questions we said, where we wanted to find our height, we have the volume equation, right? The volume is the base times the height. Our base here is x times x, right? That's what we said for base. It's x squared times the height. If we remove this equation, we could get our height is equals to the volume over x squared. Now they said the volume is 32, so we come back and say 32 over x squared. That's what they want. 32. Now in terms of x, the surface area of this open box is, okay, we take our height, we substitute it into our equation. So we have our original surface area equation, is they gave it here, is 4xh plus x squared. Substitute our height, we get it to be 4x. Our height we said was 32 over x squared plus x squared. Yeah, after you simplify this x cancels out here, and this 4 times 32 gives you 128, so it's 128 over x plus x squared, and that's what they want, 128. Okay, now this next part, they want us to derive this. Okay, so to derive it, I need to get it in a form where I could start deriving. So we get rid of the denominator, take x up, so it's going to be 128 times x to the minus 1 plus x squared. Okay, yalla, so now we can start deriving, right? So s prime is going to be minus 128 times x to the minus 2 plus 2x. Now this x is negative, so we'll bring it down, so we get it's minus 128 over x squared plus 2x. That's the 128. Now here they want us to put this equation equated to 0, So if you equate this whole thing to 0, you could shift solve and you get x is 4. Now this last part, the height for which the surface area of the box is minimal. Okay, so now we have our x, right? Now we could go back to our height, which was what? Is 32 over x squared. Now that we know x, we could just substitute 32 over 4 squared, because that's what x is, yeah? So it's 32 over 16, so height is 2. Okay, number 12. The function f is defined by this equation, where c is not 0, where c is a constant. The roots of this equation are r and minus 4r. Okay. Now remember, when we have the roots of an equation, that means the equation just simplifies into x minus our first root times x minus our second root. So now they told us here our roots are r and minus 4r. So we go x minus r and x plus 4r. Yeah, because minus 4r, so it's plus 4r. Okay. So now you expand this. Okay, you take these, you multiply them. So you get x squared plus 4rx minus rx minus 4r squared. Simplify this equation, you get x squared plus 4rx minus rx, you get plus 3rx minus 4r squared. Okay. Now once you've completely simplified this equation, you're going to want to write down our original equation, which was what? X squared plus 12x plus c. So x squared plus 12x plus c. Okay, and now you're going to want to look, you're going to want to compare these parts. So 3r is equals to 12. And here, this minus 4r squared is the same as c. Yeah? Okay, so now really easy. You just take these down and put them equals to each other. So 3r is equals to 12. So you get r is 4. And now you put minus 4r squared equals to c. Substitute r, since we know it now. It's minus 4 times 16 equals to c. So you get c is minus 64. Yes, so we take that. That's what they want. They want r is 4. C is minus 64. 4, 64. Let C in factored form f of x equals to. Okay, remember we said that now our equation is x minus our first root and into x minus our second root. Okay, now we said our first root is r. So x minus r into our second root is x minus 4r. Okay. Wait, my bad, no, this is x plus 4r, because here it's minus 4r, so minus minus cancel, so it becomes positive. So it's x plus 4r. Okay, so now we're just going to substitute. Instead of r, just put 4, so x minus 4. And instead of 4 times r, just substitute again. So it's 4 times 4, so 16. Okay, part D. The coordinates of the turning point on the graph of f are what and what. Okay, so when they want the coordinates of a point, we're also going to do the table, the x, y prime and y table. But to use that, we need the original equation, right? So here's our original equation, and we found c already, so I'll rewrite it with our c. So it's going to be x squared plus 12x plus c we found to be minus 64. So we're just going to write minus 64 على طول. Okay, and we derive this. Okay, to make it y prime, get 2x plus 12. Yeah, this is all because we want to make this table, the x prime, y, and so on. Okay, we got it to be 2x plus 12. Okay, 2x plus 12, you equate this to 0, and you get x is equal to minus 6. There's nothing else, there's no other value, so you just write down minus 6. Now you test a value here and the value here. Here I'm just going to test 100. Here you test minus 100. Okay, so you put the minus 100 in the derivative. Yeah, you put this minus 100 in our derivative. So if you do that, you get a negative number here, and here you get a positive number, okay? So you can see here that it's going down and then goes up. So this is the turning point that they want. It's at x is minus 6. So you write down minus 6 here. Now to get the y value, you just take this minus 6 and put it in our original equation up here. So instead of x squared, you just substitute. So it's minus 6 squared plus 12 into minus 6 minus 64. You simplify and you add all these up, you get negative 100. Best, that's what they want here.